Well, hello and welcome back to math class. As you can see in front of you, we are going to do lesson 3.3. So you're going to need your notes out and a pencil for today. We're going to continue talking about ratios, and we're going to this time add tables to it. Ratio tables are very similar to what our Math 5 a Day has been doing us for the last 12 weeks. So this should be a lesson that's not too challenging for most of us. So it says here, you can find and organize equivalent ratios in a ratio table. You can generate a ratio table by using repeated addition or multiplication. Let's go ahead and underline that so that we know we can use addition or multiplication. All right, first, example 1, completing ratio table. Find the missing values in each ratio table, then write the equivalent ratios. Well, as we noticed here, we have one triangle has 3 sides. 2 triangles then would have 6 sides. Looks like we have a pattern here where we're counting by 1s on the top. And it looks like the pattern on the bottom is we're counting by 3. So the last one would be 12. So if you notice, let's just put this on here. We're adding 1 each time. Down here, we are adding 3 each time. It says here that we need to write the equivalent ratios. Well, if you notice, here's our first ratio. So we're going to write here 1 to 3. The next ratio we have is 2 to 6. Then we have 3 to 9. And last but not least, 4 to 12. These 4 ratios are equivalent to each other. That means if I would simplify 4 to 12, it's going to equal 1 to 3. The same thing, 3 to 9 simplified is 1 to 3, and 2 to 6 is 1 to 3. All right, let's look at here. We have frogs and toads. So we have 4 frogs and 6 toads. If we look, how did we go from 4 to 20? You are correct. We multiplied by 5. So whatever we did up here, we did down here. So 6 times 5 is 30. Next we have here a 90. Now we can do 2 things. We can either start from the 6 and go all the way to the 90, or let's just look here at the 30. This one will work easily. Let's see, 30 times what is 90? 30 times 3 is 90. So then we have to do the same thing on the top. 20 times 3 is 60. So as you can see, it's not quite as a pattern like it is here with the triangles. We counted by 1s. This is kind of counting by all kinds of things. So that's why we need to find missing pattern. All right, well, let's see here. We have 180. I'm going to go ahead and I'm just going to say I know that 60 can be multiplied by 3 to get 180. If I take 60 times 3, I get 180. So 90 times 3, well, 9 times 3 is 27, and we add our 0. All right, so let's go ahead and list our equivalent ratios. So here we have 4 to 6. We have 20 to 30. We have 60 to 90. And last but not least, we have 180 to 270. All 4 of these ratios are equivalent to each other, which means if we simplified all of them, these both can be divided by 2, which means it would equal 2 to 3. If you simplified this one, took your zeros, it's going to equal 2 to 3. This one here would equal 2 to 3. They all equal 2 to 3 when simplified. All right, let's go down to the try it. I'd like for you to go ahead and pause your video, if you would, and see if you can solve the missing numbers. Those of you that don't want to solve it because you don't think you can handle doing it on your own, then you can keep playing it, but the rest of you pause and then turn it back on. Okay, so those of you that finished, or those of you that just want to watch, I'm going to look here and I have to find the missing number right here. Well, let's see. From the hands and people, 2 people, we have 4 hands. So let's see. If I have 4 people, that's 2 times 2. Whatever I do here, I have to do here. So I'm going to multiply 4 times 2, and that would be 8. I can't really take 8 into 12, can I? So I'm actually going to look here at the 4, and I'm going to use a different color so I can see. I can go from 4 to 12. 4 goes into 12 3 times. 4 times 3 is 12. Well, since I started here at the 4, I have to start here at the 2. And I start here and I go from here all the way over. Let's see, I multiplied by 3 up here. So let's multiply by 3 down here. 2 times 3 is 6. All right, so now I have, oh, look at this one too. I can't take 12 into 16, but I could take the 4 or the 8. Which one should we do? I think I'm going to do the 8. So I'm going to go from here, which is the 8, and I'm going to use a green here. And I'm going to go from 8 to 16. 8 times 2. But the rule is, if I start here, then I have to start down here, and I have to go from here to this box. I multiplied by 2, so I have to multiply by 2. 4 times 2 is, and I'm going to use a different color so you can see it, 4 times 2 is 8. Now the other pattern you can notice is we actually were counting by 4s on the top. 4, 8, 12, 16. Down here we had 2, 4, 6, 8. So maybe some of you found the pattern that way. Let's see if the pattern over here works the same way, as simple as that. 3, 6, oh, that works. So this we take it times 2, which means we do the same thing here. 4 times 2 is 8. Well, if I'm counting by 4s up here, 4, 8, that should be a 12. So that one doesn't work as easily as this one does. So let's see, I think I'm going to have to take 8 times 3. 8 times 3 is 24. 6 times 3 is 18. Now I have to go all the way to 180. Well, I think I'm going to take this 8 right here all the way this direction, because I know if I take 8 times 10, so let's take down here 6 times 10, and that's 60. This one was just a little bit more challenging. Now we have to write the equivalent ratios. Well, let's go over here and let's write these first. We had 4 to 2. 4 to 2 is equivalent to 8 to 4, which is equivalent to 12 to 6, which is equivalent to 16 to 8. On this side, we had the ratios 4 to 3. It's equivalent to 8 to 6, which is equivalent to 24 to 18. And last but not least, 180 to 60. This looks like it's the value. It's simplified, which to me means all of these, if they were simplified, would equal that. On this side, this one is not the value, because we all know that 4 to 2 could actually reduce to 2 to 1. That means every single one of these ratios, if they were simplified, would equal 2 to 1. All right, let's go ahead and move down to the bottom part of our paper. It says here you can also generate a ratio table by using subtraction or division. In summary, you can find equivalent ratios by adding or subtracting. We did that up on the top. And then down here, it says multiplying or dividing each quantity in a ratio by the same number. Let's look and see what we can do down here on these examples. Find the missing values in each ratio table, then write the equivalent ratios. All right, well, let's see. They go from here, they go 100 to 300, 300 to 900. What do you think we are missing? It looks like to me they multiplied this by 3. So, of course, whatever I do here, I have to do here. So 1 times 3 is 3. All right, well, let's see. 900. Well, it looks to me if I would start with this 300 right here and multiply it times 3, that gives me 900. So now whatever I do down here, I have to do the same up here. And it looks like 3 times 3 is 9. All right, let's look at this last hard one here. We have an 8. 9 cannot go into 8. 3 cannot go into 8. So, oh, wait a minute. Let me see. I think we could start here with this 1 way over here. This 1, and let's go ahead and highlight it. This 1 right here can be multiplied by 8. So, of course, whatever I do there, I have to do on the bottom here, which means now I have to take this 100 times 8. 100 times 8 would be 800. My equivalent ratios are 1 to 100. That's the first one. It would be the same as 3 to 300, 9 to 900, and last but not least, 8 to 800. Now, some of you won't need to do all of this because you can actually see the patterns ahead of time. On your homework today, you are going to have to list the equivalent ratios, so make sure you understand that. All right, let's look at problem B. 3 to 1. Oh, my paper turned here. 3 to 1. Oh, I doubled this. It looks like we doubled this here. 1 times 2. So let's take this 1 times 2. 3 times 2 is 6. The next one, it looks like from here to here, we divided it by 3, right? 6 divided by 3 is 2. So let's do 2 divided by 3. Oh, that's going to give us a decimal or something. So we're just going to write the fraction like this. 2 divided by 3. 2/3. This is a challenge one. Now we went from 2/3 to 5/3. Well, let's see. I took 2/3 plus something to equal 5/3. 2 plus 3 is 5. The denominator has to stay the same. So we basically added 1. That's kind of crazy. So that means we're going to do up here. Plus 1. And the answer is 3. Now, you're not going to have a lot of them like this. This is kind of a challenge problem to do. All right, go ahead and pause your video if you are so inclined. See if you can solve these for me. Go ahead and pause it now. For those of you that don't want to pause it and are struggling, then you can continue to play. Let's go ahead and see if we can solve these problems. All right, well, let's see here. 1 times 2 is 2. 5 times 2 is 10. Oh, I can do this one. 2 times 2 is 4. 10 times 2 is 20. Ooh, that's a 15. I don't think any of these go into 15. However, if I look way back here at the number 5, it can go into 15 3 times. So I'm going to start here with the 1, and it can go 1 times 3 would be 3. So my equivalent ratios are 1 to 5, 2 to 10, 4 to 20, that's not a very good 0, is it? And 3 to 15. All right, let's look at our last one here. This one, take that and divide that by 2, which means I'm going to take that and divide that by 2, which would be 1. I took this times 4, so let's take 12 times 4. That's 48. 48 and 36. It's not, I don't really want to do that one. I'm going to start here way over at the 12. I'm going to take 12 times 3, which means I'm going to start right here. I have to do the same thing. I'm going to take it times 3, and 1 times 3 is 3. My equivalent ratios are 24 to 2, 12 to 1, 48 to 4, and last but not least, 36 to 3. Okay, you can go ahead and stop, and we will do the back side of our notes in our next math class.